Hello friends, in this video I'd like to solve the following problem from the Croatian Mathematical Olympiad for 12th graders, 1996, problem number 3. Let t be a number between 0 and 1. We wish to find all functions f from the set of real numbers into itself, which are continuous at 0, at which satisfy this equation f of x minus 2f of tx plus f of t squared x equals x squared for all real numbers x. So here are my hints for this problem. First, continuity at 0 means, and the fact that t is between 0 and 1 means that if we take limit with higher and higher powers of variable t times x, well, this argument tends to 0, so by continuity we get f of 0. We can take our limit inside for any real number x. And my second hint for this problem, try replacing x by tx, t squared x, t cubed x, and t to the power n minus 1 x, and try writing these equations together and adding them. And also recall this well-known fact that 1 plus q squared and so on plus q to the power n minus 1 can be written as 1 minus q to the power of n over 1 minus q, for any number q which is not 1. So give this problem a try and I will see you in just a minute. Right, so let's take our equation. Here it is. And now what I wish to do is to replace, first, let's replace every occurrence of x by tx. We will get the following. Then let's replace again every occurrence of x by tx, and we will get the following line. And so on. I can continue writing these types of equations, and I will write the last three equations: t to the power n minus 3, t to the power n minus 2, t to the power n minus 1, x minus 2f t to the power n minus 2x, t to the power n minus 1x, f t to the power of nx, plus f t to the power n minus 1x, f t to the power nx, f t to the power n plus 1x equals, well, each time it's t to the power n minus 1x squared, t to the power n minus 2x squared, t to the power n minus 3x squared. Right, so we have this huge system of equations. And now, let's add them together. Notice the following fact. For example, here we have something, minus 2 times the very same thing, plus the very same thing. They cancel. Likewise, the next line will cancel, and the next one, and so on. Here it will cancel as well. These two terms and the previous term will cancel as well. And these three will also cancel. And after a bunch of cancellations, we will be left with the following: f of x minus f of t times x. Yes, because here we have 1 and here we have minus 2, so it's minus 1. These will partially cancel with that. We'll have minus f t to the power of nx plus f t to the power n plus 1 x, which equals, and let's add the right hand side, we can factor out x squared, and I will have 1 plus t squared plus t to the 4th power, and so on, and so on. Finally, we will have t to the power 2n minus 2. And now I can write this all in the following way: f of x minus f of tx equals, and let's put these terms on the right hand side, equals f tn x minus f t to the power n plus 1x plus, and this part can be written as x squared 1 minus t squared 1 minus t to the power 2n. Very well. Now let's take crucial step. Now let's go to infinity. So let n diverge to infinity. Notice that since f is continuous at 0, since our function is continuous at 0, we have limit as n goes to infinity of f tn x. We can put our limit inside and we'll have just f of 0 for any x whatsoever. Likewise, limit of f tn plus 1x, we also can take our limit inside because our arguments tend closer and closer to 0, and it is also f of 0. So we will get the following. On the left hand side, we have f of x minus f of tx, and on the right hand side, this goes to 0, f of 0, this goes to f of 0 as well, so it disappears. And notice that this part, f of t to the power 2n, since t is between 0 and 1, it goes to 0, because t is between 0 and 1. Alright, so we are left with this nice expression. X squared 1 over 1 minus t squared. Alright, so I have this equation which is easier, simpler than the previous equation. And now I will do what exactly? The same thing. I will be replacing x by tx. So maybe let's write it. Let's rewrite our equation once again. And now let's replace x by tx. Let's do it once more. T squared x minus ft cubed x equals t squared x squared 1 minus t squared, and so on and so on and so on. The last two equations will be t to the power n minus 2x minus f t to the power n minus 1x equals t to the power n minus 2x squared 1 minus t squared, and this line. Alright, and now again let's add all of these equations together. Let's add them together and we will have the following. Let's take a look. This cancels with that, this cancels with that, and so on. Everything cancels apart from f of x and minus f e to the power of nx, which equals, well, and on the right hand side we can factor out x squared 1 minus t squared, and we are left with 1 plus t squared plus t to the 4th power plus t to the power 2n minus 2, and we can do simplification. F of x equals f t to the power of n x plus, and that converges, we can write in the following way. It's 1 minus t squared squared 1 minus t to the power 2n. And again, let's take n to infinity, and we'll have the following. On the left hand side we'll have f of x. On the right hand side this goes to 0, so we have f of 0 again by the continuity of at 0. this goes to 0. So we have plus x squared 1 minus t squared squared. And that is our formula for our function. Again, what is f of 0? Well, f of 0 is some constant. So maybe let c be equal f of 0, and we have this general form of our solution. X squared 1 minus t squared squared plus c, where c is some number, it's some constant. But now we have to do verification. So let's do it. Verification is rather simple. Verification. So on the left hand side of our equation, we have, let's go back because I don't remember exactly. On the left hand side, we have f of x minus 2 times f of tx plus f of t squared x. So we have f of x minus 2 times f of tx plus f of t squared x, and let's plug it in, our formula. So it's x squared 1 minus t squared squared plus c minus 2 tx squared 1 minus t squared squared plus c plus t squared x squared 1 minus t squared squared plus c. Alright, now here we have plus c minus 2c plus c. C disappears, and we are left with x squared minus 2t squared x squared plus t to the 4th power x squared all over 1 minus t squared squared. And notice that we have 1 minus 2t squared plus t to the 4th power, and if we expand our denominator, we will have exactly the same. So we are left with just x squared, which happens to be the right-hand side of our equation. So it is verified, it is indeed the only solution. So the only solution of our equation is this function right here. And that closes our problem. Continuity at 0 was crucial for this problem to be solved. Yes, thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye.